just trying to sort out this slow wind problem on these GX-77 recorders. I've got an ammeter in series with the spool motor and the voltmeter, which is measuring the voltage to it, which should be about 16 volts on spooling, and the ammeter here, I've set it to on the 10 amp scale at the moment. But if you see, when the spool is heavy and we try and spool it, its the voltage has dropped to 12 volts and the current's just over 1, about 1.2 amps, and it won't do it. But if you give it a helping hand, it can just about get going, and the voltage is still 12 volts. Current is just over 1 amp. It's the 1 amp scale, and it's not going very fast. So it either needs more voltage or the drag through the system here. This is free running, this one on this side, these spool motors, so it's having to spin that as well, and that does have a small resistor diode across it, which is an additional load because it's acting as a generator, so it's all acting against this motor trying to turn this spool here. If you stop it, the voltage goes down to 0 because there's nothing now. Now if you spool it the other way, when this is light, it manages to spool. This voltage, by the way, is the generated voltage on this motor, which is free running, but it's acting like a generator now. So as you can see, it's actually generating 7 volts. That's why it has a resistor and diode on a circuit there to absorb the energy. If you didn't have that on there, that voltage would feed back to the control circuit, which is probably not a good idea. I don't know what the rating on the transistors are, but it's up to 10 volts now. So that's just been, if you didn't have that resistor and diode, the voltage would be probably a lot higher. This one's starting to get heavy now, and this is the one doing the winding, and it's already beginning to slow down. This machine's in pretty good condition, and the brakes are not binding or anything, so it's just the DC motors are just too weak. The spool motors, it's really slowing down now. In fact, if I stop it, it'd probably struggle to start. Yeah. If you release the tension on this side, it does help as well. But so if this reel was to run in the opposite direction, it would probably the two of them working together would probably do it. Winding back the other way, current jumps up, it's just over 1 amp. It's getting about 14 volts at the moment from the circuit power supply, 15. While it's free running, I think it should be about 16, showing about 15. But as the load increases, that voltage goes down. But I don't think increasing the voltage from the regulator is by 1 or 2 volts would be enough. So I'll keep looking into it, see if I can find a solution. Checking the motor on the other side, see if they're the same, got the voltmeter and ammeter, but the heavy reel on this side, so try and spool it. That way it's alright, but when we spool the other way, you can see the belt's actually slipping on there. If we give it a, It's got 12.5 volts, drawing just over 1 amp. Give it a helping hand. So if you release the freewheeling spool, it does start going. And the current is just over 1 amp. And the voltage is still quite low. Oops. So I'm going to have to do a circuit mod. I'm going to do a relay mod on this so that I can switch the voltage to the spools to help it spool quicker. I've got a lot of voltmeters connected up, but you can ignore most of those. I've got a little 24 volt relay on a little circuit board which you can buy very cheaply. They're just a couple of pounds. The 24 volt relay, it's 2 amps, which would be enough. You can just buy a relay on its own if you want, but soldering all the wires to the terminals on the bottom, you can bust the terminals off if you're not careful. So this board was nice and cheap, and it's got these screwed terminals. It's a 2-pole changeover relay, so it's got normally open, normally closed 2. It also comes with a little light. Now I've connected this across the spool in motor. I've got a circuit diagram I've worked out here. I'll explain this a bit later on, but just connecting the relay across the motor just to check that it's going to work, because it's 24 volts and there's about 16 volts comes in on fast spooling and only 5 volts or 4 or 5 volts normally. So the 24 volt relay makes sure it operates. I've connected a resistance meter across the normally closed, so when this isn't operated, it's like that. And so if I just spool it as soon as I drive this motor to the spool, the relay should come on. So the red light came on and the contact is opened. And then if I just stop it, the relay goes off and the contact goes back. Spool it the other way, remains closed, no relay operation. Even when it's running really fast and generating some generation voltage, it won't operate that relay because it's got a diode in it that stops you. So I'll explain the circuit later on, how I'm going to do it, because it requires just a little bit of circuit mod. I'm going to put a relay across each motor. When one relay is operating, when this motor's light on fast, it will switch the other motor to 5 volts forward. And now it's normally 5 volts, makes it go one way only, so you've got to switch the plus and minus on this DC motor. One contact to go to ground, and the other one I've got to just wire off up to the minus voltage on the power supply. So that's only one wire, that's not going to be difficult. Just one relay on each side. So I bought 2 of these relay circuit board. It just came in this blurb, it's very cheap, a couple of pounds each. One of these be fitted inside, be very easy to do because this little circuit board here is, and the motor wires come up to that, so it's going to be very easy to just, and there's loads of space to put it in. The wiring will be easy, and just running the 5 volts to it and just making sure that's wired up correctly. I did do a little logic drawing to make sure everything's okay. When left play, right play, left fast, right fast. And when it's switched, when you first switch the motor on, it gets a pulse to prevent tape sag. But those pulses are only 5 volts, so they're not going to operate the relay. When it's in play, left or right, the motors are only on 5 volts, so the relays are not going to operate. It's only when it goes to fast this relay here switches over and supplies 16 volts, and there's a transistor pulls down this one side of the motor. That's so the open or closed depend on the left or right reel. So even though 16 volts goes to both motors, one of these is on and one is off, so the relay is not going to operate. So it all looks pretty good. I'm going to connect it up and see what happens. The Akai GX-77 relay mods to help the spooling, fast spooling on these machines, which on a lot of machines, when the tape is full, it won't move. So here's some notes. If you intend doing this, you'll have to be meticulous and careful in the wiring, but it's cheap. As I said before, buy a couple of 24-volt relay boards. You buy these ones with the connections. They're only about £2 or £3. 24-volt relays, even got a light, and it makes it very easy to do the wiring. Obviously you'll need some wire. I've used red, black and orange, and some cable ties. Now you need two of these, one on this side and one on this side, and the wires will run along. I've bundled them up. Now it's very simple. When this machine runs in fast forward or fast rewind, there's a higher voltage applied to one of the motors only, the spooling motors. It's a DC voltage, and it turns the motor and pulls the tape through. The other motor is freewheeling, but it also acts as a generator, which adds a bit of an extra load, and it dumps the voltage it generates into a resistor. And so it's very simple operation, DC motors. Now on the circuit diagram, it's very simple. You can download the service manual on the net. There's two motors, and it just has a low voltage and a high voltage to the motors. When it's in play mode, there's a small low voltage applied to the reel, to one of the motors, just to take up the tape, because the capstan is actually pushing the tape through. And the other motor again is in idle mode. Now what we can do is, when it goes into fast spool, one motor is pulling at high voltage and the other motor is dragging. But if we can apply a voltage to this other motor to make it turn in the direction to unwind the tape, it will have no drag. Well, it's all pretty straightforward, because you don't need anything except the low voltage which is already available on these motors. But what you have to do is reverse the voltage into the DC motor, because normally it only rotates in one direction to take up the slack of the tape when it's in play. Now when the one motor's in fast spool, it's got to unwind the tape. So it's just a matter of applying the 5 volts and reversing the connection with the relay. We've got plus and minus on the motor. Normally the voltage comes to the plus side. All we've got to do is operate a relay and swap the voltage to the minus side and the plus side to earth, because normally a transistor takes it to earth, but in our case we just have a normal earth. It's all very straightforward operation. The relays operate on the high voltage spool side and operate the contacts on the other motor. But because you operate in one relay on the fast spool and wanting to do the connections on the slow spool, that's why you have to have all these wires running across. So I've drawn a drawing. If you just follow this drawing meticulously, it's very straightforward. It looks like a mess of wiring, but all it is one relay here operates the contacts on the other motor and just swaps the voltages around. if you study this properly, it's pretty straightforward. And if you're going to do it, just mark out your relay contacts like A and B, and this is the right, what's the left spool board, and this is the right spool board with A and B. The only extra wires you'll need is the plus and minus 5 volts, well, not plus and minus, the 5 volts. On the circuit board drawing, you can work it out from the circuit diagram. This is the back of the board, but I mean, you've got your high voltage to the motors and the low voltage to the motor just come off these little handy spike terminals, so it's pretty easy to work out which one is the low voltage, and that one's the earth, so I can run the earth and the plus 5, which is I need it for switching to the motor. So there's all the wiring, relays wired up, one each side. When it's I'll test it in a minute, and these can be you can put some shrink round wrap or something. There's plenty of room just to poke them inside. Just put them in there, just so they don't touch anything. So that's how it's done. It's just time consuming. You sit down with some wire and a little bit of soldering. The only soldering you have to, you take off a couple of wires off these little boards which have the motors on, and join them to the motor wire. Little join on the wire somewhere. There's one join on that wire, so nothing difficult. And this wire, just make sure it's not rubbing on anything or moving. Okay, so we'll power it up and see how it goes. Okay, the modification of the Akai with relays to operate the spool motors to give them a bit more power so that they can spool. Okay, before this spool, when it was full, wouldn't wind. You'd have to turn it with your hand to give it a go. So I fitted in some relays, double pole relays, one each side. Now, I originally had 24 volt relays on the circuit, but I found that sometimes they wouldn't operate because under load this voltage here, which is supposed to be 16, dropped to about 13, and the relay wouldn't operate. So I've swapped them to 12 volt ones. Now, just a couple of notes: if you're going to do this, you have to have a diode in with the relay. Just a very cheap diode, 1 amp on, say. Just to prevent the relay operating at any time if it gets a reverse voltage when the motor's spinning the other way. I've also put an LED in to operate when the relay operates, just to show that it's operating. You don't have to do that. I just put it in just for testing, and I'll show you them. Anyway, I put the 12 volt relays in, and they operate much quicker now and without any problem, and they don't operate at low voltage like some people might think when these are running at 5 volts. In fact, this 5 volts is always less, drops down to about 3.5 sometimes. They don't operate, especially if you have that diode in there. Also, there's a small diode across the relay just when it releases, just to absorb the release voltage and current. If you leave that out, it won't damage it, but it might slow the release down just a fraction. I didn't. They're so cheap, pennies. You might as well put one in. And otherwise, I can show you operating. Before, when this reel was full, and I pressed wind, fast wind that way, it wouldn't move. But now when we press this, you can see the relay operate, and away it goes. And then you press the other one. Oops, sorry, the wrong relay. And as I said before, these relays, these wires connect to the other motor, and the one on the other side connect to this motor, so that's why you have to have all these wires. So let's press this one. If you look at this, this one operates to provide power to the other relay. You have to get your head around it, otherwise you get mixed up. Anyway, the blue lights just are on the contacts. When those contacts operate, they provide the 5 volts to the to unwind the tape, whichever one's required. So now it's working perfectly. You put a heavy spool on there, and it will work both ways now without any problem at all. And when you press play, there's no relay operation. Press play the other way, no problems. Unload the tape and load it up. The other thing I will say, and it's probably you shouldn't do it even before, don't go from fast wind straight to fast rewind. The brakes do operate, but they don't slow it quick enough, and I found you can unwind some tape if you're not careful. I'm sure you're not supposed to do that anyway. So if you want to go from fast one way and then stop and then go to fast wind the other way, rather than going straight from fast wind to fast rewind, which I don't think is a good idea on any machine. But you can go to play. From any direction. And reverse play. And from play you can go to wind, play, and then to wind. So everything's perfect now. The relay mod does work. As I said before, you just have to get your head round the wiring. It's just methodical. That's all. Not that many people will do that now. I think that this machine was made in 1981. I'm sure there aren't many machines around now if anyone wants to do a modification on. Anyway, I fixed, as you know, I fixed the loading mechanism, which was freeze solid. Replaced the gear. And that is a common fault on these machines. The older they get, and they haven't been used for years, they seize up. And I've done the relay mod, so I'm going to put it back together again. I might do some frequency tests to show the operation of the bias circuits and that. But anyway, there you go. That's the relay mod. I can take these LEDs off now. And just wrap these up and put them inside. Again, it's a cheap LED, anything with a 1K resistor just to limit the current. I only put them on there, as I said, just to show that the relay is operating and not staying on or operating when it shouldn't be operating, because I put it's across one of these contacts. This one, when it switches this diode. Actually, it switches it to earth, and the plus comes up there.